Have you ever been out to a store and you come across a famous painting, or at least something that you think might be made by a famous artist, but you're not sure, due to the price, and you'd like to know, is it like a forgery? You know what? There's a process behind that, and it involves some really crazy science. You gotta check this out. Follow me.
This episode is funded by the Glick Fund and the Crystal Vahan Family Foundation, who inspire philanthropy and creativity.
All right, so we're down here in the basement, which is actually a fascinating part of your museum, by the way. So is this the piece that you were discussing that we're going to kind of overview?
This is the painting. This is the painting that we suspect is a forgery.
So tell me about the artist.
Well, so the artist that we think is responsible for this piece is Icilio Federico Ioni, and he has sort of a fascinating life history as well. He actually was sort of classically trained in all the proper techniques, so he was capable of completely making one of these paintings from scratch like you would have in the Middle Ages.
We usually begin with just a close visual examination of the artwork. So just to describe what we're looking at, again, this is a medieval painting, or supposedly a medieval painting. We would expect that the paint is going to be egg tempera from this time period, so it's pigment mixed into egg yolk. It's on a wooden panel, so this is a panel painting. It's a relatively large wooden panel. You can see the thickness.
Yeah, it's really thick.
So we're looking at relatively low magnification. And so what you see here is the ground layer. That white material would have been the original layer that's placed onto the wooden panel. The red layer that you see in there is material called bole. It's kind of the glue that will cause the gold to stick. And then as it is aged or artificially aged, all of these layers begin to break apart and the cracks form. So you can see several of them here in this detail image. And then inside of those cracks, you'll notice they're quite dark.
Yeah, really dark.
And so that is, under a natural condition, just an accumulation of dirt and grime and old varnish. A forger might want to enhance these cracks to make them really pop by pushing something into those crevices, perhaps a pigment or a dark resin material. So what you're looking at here is just a diffuse reflection image using visible light, what you saw when we were looking at it on the table. But then if you move that light source to the far extreme, it will begin to cast shadows, and it gives you an idea of all the surface deformations that exist in this painting. You had mentioned earlier that it's a highly textured piece, and so you really begin to pick out some of that texture, examples of the cracks that are running through the surface, the crack lure that is in the paint. Now what you're looking at is a fluorescence image. So we've shined a black light onto the surface, and that ultraviolet radiation is going to be absorbed by the varnish and the paint materials, and then it's going to be re-emitted in the visible, and that's what we're looking at here. And it really helps us to pick out some things about the condition of the piece. For instance, you can note certain areas that show up different, where under visible light they look the same. This tells us this is a modern intervention where someone has done some retouching, perhaps of a damaged area in that gilding. Now what you're looking at is an X-ray of the painting. So this is an X-ray just like you would have in the doctor's office to look at a broken arm, but instead of looking at bones and flesh, we're looking at the distribution of the heavy metal pigments in the artist's paints, as well as the density differences in the wood, and you can see examples of metal that have been driven into the wooden panel. Here, for instance, is a modern-looking nail that's going right up through the bottom of the panel. Other nails here are being used to attach this component of the frame around the top. And then you can see those two wooden dowels that were protruding in the raking light image. You can actually see that they've been filled in, or they have a different density from the surrounding wood. An interesting thing that we noted here is the little tail end of a screw buried in the back of the panel, we assume. The head has been broken off or is missing, but you can see the threads of the screw, which of course would be a modern intervention. So this XRF spectrometer has an X-ray tube that's going to irradiate a small area of the sample, about the width of your hair, with X-rays. The instrument takes about 15 seconds, blowing some helium across the surface to get rid of all the room air which would otherwise absorb our characteristic X-rays. We can identify lead, small amount of calcium, a big signal from barium. There's some zinc present. Looks like a little bit of chromium, and it looks like that pretty much accounts for it. Thinking this is a green earth, we would expect to see a certain suite of elements that show up in that mineral. So that's green earth.
Oh, wow, okay.
Sort of an olive drab color, a yellowy brownish green. But curiously, in this area, we're seeing the element chromium. And chromium is not a component of green earth. In fact, chromium might appear in a more modern pigment, a chrome oxide or viridian green. And you can also tell the color's slightly different, and the sort of aqua teal of the viridian green more closely matches what we're seeing, especially when we looked at that under the microscope downstairs. So this continues to raise our suspicion that this may not be an ancient material, but might in fact be a material that was only available after the 1800s. And that little layer of paint, what we like to collect and call a cross-section, and then we'll pluck that little layered cake sample out. We mount it in an epoxy block, cut and polish it so that we can see the full history of the artwork from the conception to the finished product at the surface. We're looking at some images of that tiny flake of paint that Glynis took from the surface of the artwork.
So if you imagine that the painting is sort of like a cake or the Earth's crust, then what we're seeing here is the top layer, like the frosting, and then that red glaze layer, and then we have this pink layer, and then below it, this sort of translucent area is the gesso, so that would have been the ground layer. And then this is a really interesting cross-section because when I take my hand away, what we're seeing here is one of those deep cracks that we saw under the optical microscope.
The real dark area?
Yeah, and so you can see that there's two kind of colors that are present, a dark, brown, black, and then a lighter brown.
This is so hard for me to get, I mean, just, it looks huge, because I'm looking, like, it looks down, but like you said, this thing is just...
Yeah, so this scale bar is 20 microns, and that's about a fifth of the width of a human hair.
Now you'll remember that the blue pigment in the false color infrared was suggestive of ultramarine.
Yeah.
So for ultramarine, from a 1300s painting, we would expect the source to be lapis lazuli. We're essentially going to bounce a laser beam off of the surface of the pigment particles and measure its scattering. And that's going to become a molecular fingerprint for a particular compound, or in this case, a pigment.
And then after doing a library match, we see that we have an amazingly good match with the reference spectrum here in pink, and that's for ultramarine. It really is a very clear...
Oh, like exact match
Yes.
almost.
And so our spectrum is coming from a synthetic version of just the blue.
Gotcha.
But we can tell that it's synthetic, and that's interesting because it wasn't synthesized until 1826.
Oh, wow.
So-
Okay. That's like a huge red flag.
We've provided some pretty clear evidence, physical evidence, that this cannot be a 1300s panel painting. There's the use of modern pigments throughout the full extent of the artwork, and they were just not available to an artist back in the 1300s. I think we're pretty much convinced that this is not
Right.
what it purports to be.